whenever we have exponential and logarithmic equations, basically we're going to do exponential today, then we'll do logarithmic tomorrow. So whenever you have exponential equations, if your bases are the same, all that means is then you can solve this if you just set your exponents equal to each other. Tomorrow, if your base of your log is the same, then you're going to be able to set the of part of your logarithm equal to each other. So if I have 5 to the 3x minus 6 power, okay, and then it's equal to 125. So what I want to do is turn that off first, and then I need to get the base of the 125 equal to, or make it a 5. So what is another way to write 125 with a base of 5? 5 to what power? 5 to the third, right? So if I have 5 to the 3x minus 6 power, and it's equal to 5 to the third, essentially what I can do is I don't really worry if the bases are the same. I'm not really worried about those anymore, and I can just drop everything off and have 3x minus 6 equal to 3. And then I'm just going to solve from there. So I'm going to add 6, have 3x equal to 9, so x is equal to 3. Then it just becomes making sure that whenever I put it back in, if I go 3 times 3, I have 9. 9 minus 6 is 3. 5 to the third is 125. So everything works out. Do the same thing on number 2. Now, I don't have bases that are the same. I have 8 to the x plus 2, and then I have 4 to the x minus 3. Again, I need bases that are the same. So, and I have this list over here from Algebra 2 where it has my squareds, my thirds, my fourths, my fifths, so on and so forth. I have a 4 and an 8. Okay? They're not both in the same list, but they are right here. Okay? I have 4 and I have 8. Right? So what's another way that I can write 4? 2 squared, right? What's another way I can write 8? 2 to the third. Now, whenever I do that, I have to make sure that if I have 8 and I have 2 to the third, I have to have the x plus 2 because it's going to get multiplied there. Same way with the 4, I have 2 squared, and then I have the x minus 3 up top. Now I have bases that are the same. Okay? 2 to the third is just 8. 2 to the second is just the 4. But I can't forget the x plus 2 and the x minus 3 that's already up in my exponent spot. Okay? Again, I have bases that are the same, so I'm not really worried about the 2's down here. Now I'm just going to solve it like normal and have 3 times x plus 2 is equal to 2 times x minus 3. So 3x plus 6, 2x minus 6, and solve from there. So I'm going to subtract 6, I'm going to subtract 2x, and I'm going to have x equal to negative 12. Second way to solve is to use a logarithm. Okay? So, second way, if I don't have anything, like I have 5 to the x power and I have it equal to 134. Okay? It's not like the 4 and the 8 where they're all in a same row. Okay? Or I can rewrite the 125 as 5 to the third. Okay, 5 and 134 have absolutely no relation to one another. Okay, so if you have two numbers that have absolutely no relationship with one another, you're going to need to use a log or an exponential, or excuse me, a natural log. It's completely up to you what you do. Okay, so like in this case, if I have 5 to the x power equal to 134, turn it into a logarithm. Remember, an exponential is just another form of a log, so I'm going to rewrite this. If I have 5 to the x power equals 134, I'm going to go log base 5. Remember, the 134 comes over, the exponent goes the other side of 134 equals x. If you have like a TI-84 that will do it with the base, do it that way. If you're just running with a TI-83 or a regular scientific or just the scientific part on your phone, I'm going to go log of 134 divided by log of 5, and I'm going to do change of base. So log of 134, don't forget to close the parentheses, divided by log of 5 is about 3.043. It's going to go about 3 decimal places. Same way on 4, I can, now it's a power of 10, so if you need to, you can write it as log base 10 of 8,000 equal to x. Okay, remember log base 10 is really just log of 8,000. And that just goes straight into the calculator of just typing in log and then 8,000 and getting x as 3.903 or thereabouts. So then I'm going to go to 7 because I'm not sure if the minus is supposed to be, I'm assuming it's supposed to be in front of the 3. But I'm just going to go ahead and go to 7 instead. So even if you have like 4 to the x plus 2 power minus 9 equal to 10, you need to get the exponent by itself first before we do anything else. So with that, I'm going to move the 9 over to the other side. So I'm going to add 9. And I'm going to have 4 to the x plus 2 power equal to 19. I still treat everything the same way. Okay, I'm still going to turn this into a logarithm. I'm still going to go log of 4, or log base 4 of 19 equals x plus 2. Now, I'm not going to do anything with the x plus 2 until the very end. I'm going to go ahead and do change of base with my log base 4 of 19, and I'm going to go ahead and set it up before I do anything else and go log of 19 divided by log of 4 is equal to x plus 2. I'll get my value there. Okay, I'm going to get my value of whatever log of 19 divided by log of 4 is first, and then I'm going to, so it's about 2.1239 whatever, okay, and then I'm going to subtract the 2. Okay, so I'm going to do what's in the box first, and then I'm going to subtract the 2, so that is about that 2.12 I'm going to go 4, it's 9/6, is equal to the x plus 2, and then subtract the 2. Okay, I'm assuming it'll probably want it to about 3 decimal places, so it's about 0.124. Okay, after I subtract the 2 from the right side and the left side. So what we're trying to do here is we're trying to factor. So what we're going to do, okay, is take what is, and I think if I go, okay, like if you look at number 3, okay, where it says it simplifying using one of the following properties. Okay, so the natural log of b to the x power is equal to whatever x is, whatever's in your exponent, times the natural log of your base. Okay, that's what you're going to want to do here. Okay, it's either that or do using the natural log of e to the x power. Okay, that's if you have an e. Now what we did is we basically used the majority of like 4 and 3, 4 and 7 is we went here. Okay, it's the ones that have two different bases that are set equal to each other is that you're most likely going to use this operation. Okay, where you're going to take the natural log of whatever your base is, okay, that your base is going to be an actual number, 4, 5, 7, whatever. Okay, and then you're going to factor out your exponent or your x plus 2 or whatever you have, okay, and go from there. So what I'm going to do here on, where'd it go? On 8 is that I'm going to take the natural log of 5 and I'm going to multiply it with x minus 2. And then I'm going to do the same thing and I'm going to have the natural log of 4 and it's going to get multiplied with 2x plus 3. Okay, I'm still solving for x. Okay, so what I want to do is I want to distribute that natural log of 5 to everything inside. Okay, because the natural log of 5 is just a numerical value. The natural log of x times 5 is not a numerical value. Okay, because it has that variable. Now, what I would suggest to you is whenever I do this is I would take whatever I have in here and put it in front. So like I'm going to have x times the natural log of 5 minus 2 times the natural log of 5 equals 2x times the natural log of 4 plus 3 times the natural log of 4. Okay. Here and here are numerical values. Like if I could literally type in the natural log, negative 2 times the natural log of 5. And it would spit out some sort of random decimal. Okay? That is just the two things that are in the yellow are just numbers. Okay? They're really funky numbers because they're just long, drawn-out decimals. Okay? I'm not really worried about the numerical side of it until the very end. Okay? So I have x times the natural log of 5 and I have 2x times the natural log of 4. Okay, so what I want to do here is I want to put all the x's on one side, and I want to take all of just the regular natural logs and put them on the other. So I'm going to take x times the natural log of 5. I'm basically going to take that over here, and I'm going to take this part over to the other side. Minus 2x times the natural log of 4 equals 3 times the natural log of 4 plus 2 times the natural log of 5. Questions? Oh, everything on the left side is over there because it has an x times the natural log of 5 or the natural log of 4. Okay? What do I have in each term? An x. So what do you think I'm going to do here? There you go. Yeah, I'm going to take it out or factor it out. Okay? So what's going to happen here is I'm going to have x times the natural log of 5, which is just a number, minus 2 times the natural log of 4, which again is a number, and then it's equal to 3 times the natural log of 4 plus 2 times the natural log of 5. Now, again, I'm trying to get x by itself, so what do I need to do to the left side in blue? What do I need to divide by? If I just divide the whole right side by the natural log of 5 minus 2 times the natural log of 4 and do the same thing to the right side, that's going to cancel. So I'm going to have x equal to all of this. Okay? Now, those are all numbers, right? Okay? They don't look like it right now because I have the natural log of 4 and I have the natural log of 5 and all this and that. Okay? But I got x by itself, which is what I want. Okay? So what I'm going to do, whenever I go to I have natural log, 3 natural log of 4 plus 2 natural log of 5, and then it's all divided by the natural log of 5. So all I'm going to do is just go to a calculator, it doesn't matter which kind, and I'm just going to type it straight in. Okay. What I would suggest doing is putting grouping around like the top and then the bottom. So like I would go parenthesis and then 3 natural log of 4 plus 2 natural log of 5. Close that and then divide it by the natural log of 5 minus 2 the natural log of 4. Okay. All I did was just type in what I had. The 3, you can put the times, but if you just put 3 natural log of 4, it's going to know that you're multiplying here. Okay? 2 natural log of 5, it's going to know you're multiplying. The biggest thing that I would tell you is making sure whenever you do type this in that you make sure you put parentheses around it and that you close the parentheses there and here. Okay? Again, don't get... I could probably put this as like, I can make the natural log of 4a, the natural log of 5b, and it would make a lot more sense. Okay? But we're trying to find numerical values. There, I can't find numerical values. Does that make sense? Okay. The biggest thing is, there's not going to be many of these, but just take your time. Okay? All you're doing is really just factoring and solving for x. Okay? You're not worried about this number until basically the very end. Okay? It's just making sure that you kind of have all your ducks in a row and you have everything kind of placed where they need to be. Okay? But again, if I really wrote this as 3a plus 2b and then divided by b minus 2a, you know what I mean? You could do that just fine. So don't let, like if I said that, hey, a is the natural log of 4 and b is the natural log of 5. You could do this, I feel like, no problem. But I understand that whenever we throw extra parts in front of you, okay, more letters, more numbers, and stuff like that, if you need to give them an arbitrary value, like an A and a B or a Q and an S, whatever, do that. Okay? Whatever's going to make it easier for you. If you need to simplify it that way and say, okay, I'm going to let this number be A and this number be B, and just kind of go from there and make sure that I get everything else on one side and I make sure that the X is on the other, then do that. Okay? Don't let it overcomplicate things just because we're dealing with the natural log of 4 or the natural log of 5. Okay? Again, those are just numbers, is all they are.